All right, where do you want me to start? One. Number one. Are you kidding me?
Before we start, did you ever find
Too late, we already started.
The ads on your
No, I couldn't figure that out. I couldn't get any of them, any ads. So,
Did you make more money?
I'm up to $3 now, yeah.
How do you make that money?
$3.
Do they just like put it on your credit card?
Find it so you can take a video of
And,
your picture.
somebody told me you have to make $5 for them to send you a check. I have no idea how that works. I'm pretty sure when I'm like 65 years old, all of a sudden the check for $50,000 is just going to show up. Something went viral.
I think we should get a check of it though, because we're kind of.
Okay, I'll divide it between all of you guys. I'm going to make penny. Okay, tangent of pi over 4. Remember, this is the thing where we're looking at the unit circle. You're locating pi over 4 on the unit circle. You're figuring out the x and y coordinates, and then you are using the fact that tangent equals y over x to answer the question. So, donde está pi over 4?
1.
Wrong. What? 45 degrees. So it's going to be right here. So then you have to figure out what the coordinates of that point are. And so you've got yourself a 45, 45, 90 right triangle. So it's right. The answer is going to be 1 because this is what? Root 2 over 2. And this is root 2 over 2. So if I go y over x, that's going to be root 2 over 2 over root 2 over 2. And since both of those are the same, the answer is 1.
You just shut me down as an answer.
I did?
Yeah.
Oh, because I thought you didn't answer the question I asked. You answered the final answer question. So I wanted to know where was pi over 4. Okay? So we can do one more of those, and then I'm sure you can do the other two by yourself.
The last one's kind of weird.
You want me to do number 4?
Yeah.
Instead of, okay. So let's
So is
do,
number 3 -1?
Is 4 no solution? Or undefined?
we'll do 4 in a second. I believe 3 is going to be -1, yeah, because it's going backwards.
And tangent of 3 pi would be 183.
You here for me? Okay. Is my limo ready? Okay, so where is -3 pi over 2? I have to go around in the negative direction, right? Pi over 2, pi, 3 pi over 2. So the point is right here. What are the coordinates of that point? 0, 1. And so yes, if you try and go, bless you and get inside, if you try and go y over x on that, then you get 1 over 0, which is undefined. Which is why, if you think about the graphs of the tangent function that we've been doing, there is an asymptote at pi over 2, and there is also an asymptote at 3 pi over 2, because the function is undefined at that value. Okay? All right, what else?
5.
5 through 7.
Again on 6, there's an S thing, so.
Oh, we don't have to do 6.
Oh, you don't have to do 6 because it's got that typo. I don't know what that is.
Sketchy alien writing.
I don't know what that is even supposed to be. Okay, so this is on the graphing calculator. It says graph each function on the interval from 0 to 2 pi and -200 to 200. What are those little things? Well, those must be pi's. Okay.
Where?
That's the only thing that makes sense. All right, so first thing I'm going to do is I'm going to change my window. It says 0 to 2 pi, so I have that already, but if you don't, you'll want to change it to match. And then my y minimum needs to be -200, and my y maximum needs to be +200, okay? And so we're going to graph 200 tangent of x. So that graph looks like that. And we want to evaluate each function at x equals That's got to be a pi. Pi over 4, pi over 2, and 3 pi over 4. All right, so what was my x scale? Oh, I went by 1. Let's go by pi over 4. And I'll make this a little bit easier. So pi over 4 is right here. What is the tangent equal there? How do we figure that out? You would just do the little trace thingy?
Yeah.
Okay, so I hit the trace button, and I need to come over here to pi over 4. Where are you, pi over 4? Where are you?
Yeah, I have no idea what we're doing right now.
I can't find the little dude doing jumping jacks right now. Oh, there it is. Okay. So, does this look like about pi over 4?
I don't understand why you wouldn't be good.
No, it doesn't.
Yeah, it does.
Go up.
Does that look like pi over 4? Okay, so at pi over 4, y equals about 158. Okay? What does it equal at pi over 2?
Approximately.
Are you 16?
Approximately pi over 2 is right here, right?
Let's multiply it.
What's happening right there at pi over 2? Anyone just chime in now?
It's doubling,
It's not doubling.
tripling,
What's that pi over?
halving.
There's a
Asymptote.
asymptote, so the function is undefined there at pi over 2. So undefined at pi over 2. Where's 3 pi over 4? Like right here? So let's find the little dude here jumping back.
You're gonna have to zoom out.
You're going to have to do that.
I know.
Where are you? Oh, there it is. Okay, so does that look like about 3 pi over 4?
Approximately,
All right, so let's go with 180. All right? And I don't want to do, yeah, thank you, negative 180. Let's not do 6 or 7. Those are done.
Why wouldn't it be negative 1?
Okay, negative 181. A little bit smarty pants.
yeah.
Jeez. And then you're going to ask me how I got that?
No.
Because that's what you like to do, is give me the correct answer and then say I don't understand that. How did you get that? Well, you just told me. All right, so don't do 6 and 7. All right, each graphic calculator screen shows intervals of 0 to 2 pi. What is the period of each graph? What's the answer for number 8? What's the period of a regular tangent function? Pi. How many cycles are they showing there? 1, but that's from a distance between 0 to 2 pi. So how many cycles would there be in distance 0 to pi? 1/2. So for number 8, the period is 1/2. Because if it takes from 0 to pi to get, or 0 to 2 pi to get a whole thing, then between 0 and pi, they're only going to get in half of it. Okay? How many do you have there at 9?
5.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So between 0 to pi, you would have 5 of them. So what would my period be then? 2 pi over 5. I think I got number 8 wrong.
Pi over 5?
Yeah. Because remember, normally the period is pi.
Oh,
Okay, so if there's 5 of them in between 0 and pi, that's got to be pi over 5, which means I'm pretty sure I did this one
So that
wrong.
would be pi over.
Well, normally there'd be one of them
So would
between.
it just be pi?
Would it just be, no,
I
because
don't
it's,
want 5.
I think it's pi over 2. Is it pi over 2? Yeah, okay. So it's half, but it's half a pi. It's half a pi. No, never mind. We'll do that. Forget it. It's actually 2 pi, but that's okay. Yeah, that's okay, number 10. Identify the period and determine where 2 asymptotes happen. So we were working on this yesterday when we were going through your book assignment. What is B? Nope.
Theta. No. It's 0.
B never has a
It's
theta in
0.
it.
There's no
Nope.
B.
Where's the B?
Where's the B at?
It's It's in front of the variable.
Definitely one.
Definitely
Pi.
not 1/2.
Oh, duh.
Because it's theta over 2, so it's
But
1/2
theta.
theta. Okay? So normally the period is pi, but now b is 1/2, so it's pi over 1/2, which is 2 pi. So the period is 2 pi, right? So that means that there will be an asymptote adonde.
Pi over.
The first asymptote is always at half of what the period is. So there'll be one at pi, and then we'll do the force trick and just say plus or minus pi. Pretty exciting stuff.
So this one is.
So 11 is a little bit weird because it's got a pi in there already. What is b?
1/2 pi.
Pi over 2.
Right, pi over 2. So the period is pi divided by pi over 2, which is going to be pi times 2 over pi, which is 2. So there will be an asymptote at 1 and -1.
I understood that one.
Good. Take a second to do number 12 on your own.
Get it?
Okay, so
Sketchy.
number 13 says sketch the graph of each tangent curve in the interval from 0 to 2 pi. So what's the period? What? The period is pi. Yeah. Because it's 1 theta, and so the period is just pi. So there's going to be an asymptote at pi over 2, and there's going to be an asymptote at 3 pi over 2, and since it's negative, that means it's going to go down instead of up.
Oh, I forgot to draw my asymptotes.
Technically, the 2 in front of there makes it go down and up faster. It makes it steeper, but and same dealio for number 14.
Is it? Or just one?
So B is what?
2.
2. So the period is pi over 2. And remember, they want us to draw this in the interval from 0 to 2 pi. Where's the first asymptote going to be?
Pi over 4.
Pi over 4. So here's pi over 2. There's pi over 4. So there's an asymptote. There's going to be another one there. There's going to be another one here. Another one. Andy doesn't like it. And this one's going down also instead of up. What's not to like? Yeah, tangent is gross. Like I said, we don't hardly work with tangent at all in the future math classes. Not the graphs. I mean, the tangent function, yes, but the graphs, no.
All right.
Okay, 15. I'm pretty sure you guys got all that on your own. Look, they're state champs. Okay, 15, a banner hangs from the ceiling of a school gym as shown at right. The function y equals 15 tangent theta models the perpendicular distance from the ceiling to the tip of the banner.
Can we not do this?
The banner is 30 feet wide. Graph the function on a graphing calculator. Okay, done. How far down from the ceiling does the banner hang when theta equals 30 degrees? So you just have to plug in 30 degrees and 35 degrees. So this is just all calculator work. The only difference is you need to be in, because it says 30 degrees, so you need to be in radians. Radiating my daughter. need to be in degrees.
Whoa. I just got caught up. How do you do that?
Now I don't know how to feel.
Hit mode.
I don't know how.
Well, if you don't know how you feel, then I haven't made myself clear enough. Oh, Taylor. Okay.
Okay, now I just got all awkward.
So you graph the function on graphing calculator. We don't need to do that because that's just busy work. How far down from the ceiling does the banner hang when theta equals 30 degrees? So we got, did you change your mode to degrees?
No, I changed it to radian.
So then you go 15 tangent of 30. You're going with 12.
I got to tangent of
8.66. How far down from the ceiling does the banner hang when theta equals 35 degrees? I don't even know what this whole problem is about. Why would a banner have anything to do with a tangent function?
Doesn't make sense.
Doesn't seem relevant at
Alright,
all.
so I like a question.
Okay.
Number 18, when I graphed it, it came up with some sketchy graph.
Okay.
Wait, we'll get there.
Let's take a look at 16 and 17 first. I'm sure you guys don't want to do any more graphs, right?
No.
Okay, so for 16 and 17, just figure out what the period is. You, again, can do that on your own. Okay?
Yeah. Okay, I got a
All right, number 18, tangent of theta equals 1/2. This is exactly the same as the cosine ones that we were solving. What?
Are you gonna change the scales?
I'm going to change my scales, and I thought you were going to say I'm going to also change my mode. Because when you're graphing a tangent function or a cosine function or a sine function, you want to be in radians. So those of you guys that were barking about getting a straight line, that's probably why. Okay? But then yes, we also need to change our window. It said from 0 to 2 pi, so I've got that going already. I probably do not need my y maximum to be, or my y to be from -200 to 200. You want to go 10? -10 to 10, that's probably still too much. What do you go? Yeah, that's probably a little bit better.
Oh, fine, I'll change it.
No, whatever. Okay, so then I have to graph tangent of theta, or we'll just use x, and then I have to graph 1/2. And what am I looking for?
Second. Intersection.
The intersection points, and so
Second.
there's only going to be 2 of them. You go second calc 5, you move the cursor until it's close to where they cross, hit enter, write down the answer, and you're all set. Okay?
So why are there only 2 points?
Because it only crosses the tangent function twice in that interval from 0 to 2 pi. If we went from 0 to 4 pi, there'd be more of them. They wanted 0 to 2 pi. Okay? All right? So crank those out and put it in.